Hi, this is Elton Malabanan with ID number K230398. And this week I learned about software configuration management and the basic steps involved in building a single program. These topics help me understand how software projects are controlled, organized, and kept stable as they grow and change. Before this, I mostly focused on writing code, but this week showed me that managing changes and builds is just as important as coding itself. One of the key things I learned was software configuration management, or SCM, and it is all about managing and controlling changes in software throughout its life cycle. The lecturer explained that software is constantly changing because of new requirements, bug fixes, and improvements. Without the proper control, these changes can easily lead to confusions, errors, or even system failures. SEM provides a structured way to track software components, manage changes, and make sure everyone on the team is working with the correct versions. I also learned about the major activities involved in SEM, such as configuration identification, configuration control, status accounting, and configuration auditing. These activities help ensure that every change is documented, approved, and traceable. With that, this made me realize that SEM is not just a technical process, but also a management practice that supports teamwork and accountability. Another important topic covered this week was the building steps of a single program. The lecturer explained that building a program is not just writing code and running it. It involves several steps, starting with compiling the source code. Compiling checks the code for syntax errors and translates it into a form that the computer can understand. If there are errors, they must be fixed before moving forward. After compilation comes linking, where the program is connected with required libraries and external modules. This step ensures that all parts of the program work together properly. The next step is loading, where the executable program is placed into memory so it can be run by the operating system. Finally, the program is executed and tested to make sure it behaves as expected. This process helped me understand what actually happens behind the scenes when a program runs. I can clearly link what I've learned this week to my software engineering project. We are developing a system that involves multiple components, files, and features. Using software configuration management will help us track changes properly. It avoids overriding each other's work and maintains stable versions of the system. For example, using version control tools like Git allows us to manage different versions of the project and roll back changes if something goes wrong. The building steps of a program are also directly related to our project. As our system grows, understanding how compilation, linking, and execution work will help us debug the errors more efficiently. Instead of guessing what went wrong, we can identify whether the issue is a syntax error, a missing library, or a runtime problem. This knowledge will save time and improve the overall quality of our software. Overall, this week taught me that successful software development is not just about writing code, but about managing changes and understanding how software is built and executed. These skills are essential for working on real-world software engineering projects, especially in team-based environments. Applying these concepts to a project will help ensure that our system is reliable, well managed, and easier to maintain. That's all. Thank you.